Right now, Saturn's moon Titan is still exhaling methane into space, and NASA has no way to stop it. Scientists at JPL and Caltech cannot explain where it keeps coming from. Every model they build breaks. Every answer opens a darker question, and what they found beneath Titan's surface is the part they're afraid to say out loud. Titan is the second largest moon in our solar system. It orbits Saturn, 886 million miles from Earth. And from a distance, it looks almost peaceful. A hazy orange world wrapped in thick clouds, larger than the planet Mercury, dense enough to have its own weather, its own rivers, its own seasons, but those rivers are not water. They are liquid methane, pouring down from methane clouds into methane lakes, vast and still and utterly alien. Titan's atmosphere is thicker than ours, even, and it is loaded with methane gas, cycling through the sky the way rain cycles through Earth's. Scientists call it the methane cycle, a perfect mirror of our water cycle, running on a different chemical on a world so cold that methane flows like a river. What they don't call it, at least not publicly, is a problem they cannot solve. Here is the anomaly. Methane should not be there, not anymore. Sunlight, even Saturn's faint, filtered sunlight, breaks methane apart. Ultraviolet radiation tears the molecules to pieces at a predictable rate. At the rate Titan's atmosphere destroys methane, every molecule in that sky should have been gone within 30 million years. That sounds like a long time. But Titan is 4 billion years old. The math is brutal. If the methane were simply left over from Titan's formation, it would have been destroyed 3,900 million years ago. And yet, it is still there, right now, churning through the clouds, pouring into rivers, sitting in seas the size of the Caspian. Something is making more. Something is replenishing it, continuously, steadily, relentlessly, and we caught it happening in real time when the Cassini spacecraft spent 13 years orbiting Saturn and watched Titan breathe. But Cassini's data created a problem bigger than the one it solved. The obvious explanation is cryovolcanism, ice volcanoes, not fire, geological vents that push liquid water and methane up from the interior, refilling the atmosphere from below. Cassini looked for them. Hard. Scientists studied every radar image, mapped every ridge and plain. They found structures that resembled cryovolcanoes, but they could not confirm them. The Cassini team published their findings, and buried inside the careful scientific language is a conclusion that should alarm you. We cannot identify the source. We cannot prove the mechanism. We do not know how Titan is sustaining this cycle. And the deeper Cassini's data was analyzed, the worse the problem became. Because the replenishment wasn't just happening. It was happening at a rate so consistent, so precise, that random geological activity simply cannot account for it. But here's the strange part. That consistency shouldn't be possible at all. Random geological venting produces spikes, eruptions, bursts of activity followed by silence. But Titan's methane levels are stable, eerily, almost impossibly stable. That kind of stability implies regulation, a system, something beneath the surface managing the flow with a precision that volcanoes, even ice volcanoes, do not produce. Some researchers have raised a possibility the field does not broadcast widely. Titan may have a subsurface liquid water ocean, not methane, water, mixed with ammonia sitting beneath miles of ice and rock. And if that ocean is chemically active, if it has been reacting with silicate rock below it, producing methane slowly and continuously for billions of years, then Titan is not simply a moon with weather. It is a moon with a metabolism. It is processing compounds from its own interior, ingesting from below, exhaling into the sky, and the chemistry does not stop at methane. Cassini detected vinyl cyanide in Titan's upper atmosphere, a molecule that in laboratory conditions forms membrane-like structures, the architectural precursor to a cell. Scientists at Cornell ran the numbers. Vinyl cyanide membranes could, theoretically, function in liquid methane the same way lipid membranes function in liquid water. Not life, but the blueprint of it, already assembled. Already present, already cycling through a moon that breathes. NASA's Dragonfly mission is already built and heading there. A rotorcraft the size of a car, designed to fly through Titan's dense atmosphere, land on the surface, drill into it, and analyze what it finds. It will not arrive until 2034, 8 years from now. And the scientists behind it will tell you carefully, professionally, that they are searching for prebiotic chemistry. Chemistry that could, under the right conditions, lead to life. What they will not say, not on a stage, not in a press release, is what the data is already suggesting. That the conditions on Titan may not be waiting to produce something. That the cycle may already be doing it. A 4 billion-year experiment in biochemistry, running on liquid methane beneath an orange sky, in the dark at the very edge of the solar system. And we are only now building something small enough to land there and ask the question directly. The moon is breathing. It has been breathing for 4 billion years without stopping. Something down there is keeping it alive. The scientists sending a drone to find out have been very careful not to say what they suspect. So let me ask you instead, what do you think is breathing back?